Okay, so we picked up with finding factors of negative 36. We tried 1 and negative 36, 2 and negative 18. These all multiply together to give you 36. But the only ones that combine together to give you a negative 5, which is what we need right here, are the 4 and the negative 9. So we come over here. The 4 is a positive, so we put a plus sign. The 9 is a negative. I'm putting X's. It should be A's. The 9 is a negative, so we put minus 9. And then again, if we were to multiply that out, we would get this trinomial. Same thing over here. We need factors of 8. Factors of 8. Positive 8. They need to combine together to be a positive n. Now, we try to get factors of 8. That's not a very long list. 1 and 8, 2 and 4, and that's it. There are no factors of 8. There are no other factors of 8. And the only way we can get a positive 8 is either to multiply a positive times a positive or a negative times a negative. Either way, we're going to get 9, whether it's a positive 9 or a negative 9. That's not a positive 1. We put these two together. We multiply together, we get 8. We combine them, we're going to get 6. And it doesn't matter if we make them both positive or we make them both negative, we still get either a plus or a minus 6. Neither one of these give me this. That doesn't mean we've done anything wrong. That just means that this is what we call a prime trinomial. In other words, it is not factorable. Now, I wanted to put this example on here to make sure that you understood that not all trinomials are factorable. But I'm going to tell you right now that most of the ones that I give you will be factorable because I'm trying to build your factoring skills. Because factoring skills are going to be something that you need in college algebra. You're going to need it in pre-cal. And for those of you who go on to take calculus, you're going to need it in calculus. Factoring is super duper important, and we will do it many, many more times this school year. We'll have to do it when we do we're going to be factoring in our quadratics unit. We're going to be factoring in our polynomials unit. We're going to be factoring in our rationals unit. So we've got to do it at least 3 more times this school year. So be sure that you know how to factor. Okay, so the next kind, and by the way, your assignment that I'm giving you has 48 problems on it. Now, don't freak out, because if you'll notice, I'm working some of the problems with you. So these first 4 problems right here on your assignment are the exact same 4 problems that I just worked in your examples. So, I may make you a deal by the end of the video if you'll keep watching to show that you may not have to do all of them, but I'm not going to do that to the very end. So the next kind that we're going to work on is, it says for us to factor these. It says be careful to check for a GCF. So we're going to remind you what a GCF is. But notice that we're this time working on the ones where A is not 1. Now when A is not 1, notice right here, our A is 4, our B is 32, and our C is 48, just reminding you where A, B, and C are. Our A is not 1 on any of these, will our A be 1? So there's a couple of things that you're going to do. The first thing you're always going to do, anytime your A is not 1, is you're going to check for a GCF. Remember what GCF stands for? Think about it. GCF. Greatest common factor. So I'm looking to see if all 3 of these terms might have a common factor. Now I'm going to do this out with a lot more detail than I normally will. I won't normally do this every time, but I'm going to do it this time. 32 is 2 2 times, oh my goodness, 16. So 2 times 2 is 4. I think 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So I need one more 2. Okay, I'm factoring it out completely. And 48 is, that's way too many numbers for me. 48 is 2 times 24. And 24 is 2 times 12. And 12 is 2 times 6. Sorry about that. And 6 is 2 times 3. I'm going to double. My goodness, I'm going to silence my phone. And then I'm going to check on my calculator and make sure that I did that right. I'm going to say 2 times 2 times 2 times 2 times 3. Yep, that gives me 48. Okay. So a GCF, I would have to go through here and I'd say, okay, so this one has 2 2s, and that's all it has. So all I can pull out of that one is 2 2s. All I can pull out of that one is 2 2s. So it looks like 2 2s is what I can factor out. In other words, the greatest common factor is 4. So I pull that 4 out. It's like I'm undistributing it. This one has 2 B's. This one has 1 B, but this one doesn't have any B's. So I can't factor out a B out because the greatest common factor has to be in all 3 terms. So the factor that they have in common, the greatest one, is a 4. So if I pull that 4 out, then this term is left with B squared. This term is left with 2 times 2 is 4, 4 times 2 is 8. And now over here I have 2 times 2 is 4. And that's 12. So I factored out that GCF. Now look, what do we have left? Now we have a trinomial that might be factorable. Then again, it might not. So now we're going to look at the factors of 12, just like we did the other problems. Factors of 12. 1 times 12, 2 times 6, 3 times 4. And we're looking to see if any of these, it's a positive 12, so they're either both positive or they're both negative. They need to combine together to be a positive, so that means I do need positive. That gives me 13, that gives me 8, that gives me 7. So this is the pair that I need. So the greatest common factor 4 stays on the outside. This becomes B plus 2, and this becomes B plus 6. And that is factored completely. Same thing over here. Notice you don't have to do this step out all the time. Some of this stuff you can do in your head. I'm going to say 3 is a prime number. So is this will factor by 3. So that's 3 times 12. And 3 will go into that, I think 35 times. 3 times 35. Yeah. So that means that they all have a 3 in common. So my GCF is 3. So 3 gets pulled on the outside. What is left? Okay, the 1x squared is left. The 12x is left. And the 35 is left. Okay, the 3's came out. And that left me 1 coefficient from the x squared, a 12 coefficient in front of the x, and then the 35. So we're going to do factors of 35 because why? We now have a trinomial that has a leading coefficient of 1. Factors of 35, and that is 1 and 35. 3, nope, I don't think 3 won't go in there. 5 will go in there. 5 times 7. And it looks like 5 times 7 is it, because if you combine those two together, you get 12. And again, I'll pick this one up right where I left off.